when we were looking at our 5 studio days over this year, we realized they fell into kind of 2 groups, one bigger group, one smaller group. And this is kind of how we saw a lot of our units breaking out. There were two main ways that we could make models, and one was that the kids have all these different hypotheses that are competing, and we need to figure out which one or ones are the most accurate.
On a previous day, students conducted an experiment with aluminum in a copper chloride solution. Following detailed observations, the classroom teachers had asked students to come up with a hypothesis to explain the reaction of aluminum with copper chloride, and that the possible rearrangement of atoms should be part of their hypotheses. Overall, the classes came up with 4 main hypotheses. First, all atoms move together. Second, the elements change their color. Third, the atoms rearrange to copper and aluminium chloride. And fourth, aluminum disappears.
Reasoning with all 4 is tricky, particularly for warm-ups. So you could just model 1-1 as part of the do now. So let's just take a look at this one. Everything goes.
Yeah.
Everything gets rearranged.
Do you agree with it or?
Yeah, and then do you agree that this is what happens? Do you disagree? And just do that as the warm-up and why?
Yeah. Well, it's just the kids think that they just don't have a pure understanding of conservation of matter. And if you force it, then it looks like they do, but they don't really, I think.
And I like that we shifted the rigor to not just be about properties, but to really be about how that helps us explain the rearrangement of atoms. And then this is a nice piece. I think we do this one to help break it down a task. We do this during the warm-up and this during a closing. And if you need help with these, we can help.
What about the middle 2? Yeah.
And then these two, they're gonna weigh somewhere right after the warm-up.
And the properties like color, density, floats or sinks, dissolves or does not dissolve in water. So we went ahead and gave you the properties for all of these different combinations of chemicals. And so what we want you to do is take these properties, take these ways that we describe these chemicals, and try to support, agree, or disagree with some of your hypotheses from yesterday. So yesterday, Ms. Crystal told us about some of your ideas, and what we did is we went and made these posters to show your ideas. So let me explain them first of all. Each circle on here is an atom. Raise your hand if you're familiar with what an atom is. Okay, great. So you've used these yesterday. Each one is an atom. So this is the starting. You can see the copper chloride is grouped together, 1 copper, 2 chlorides, and the aluminum is up here. That's the same for every hypothesis. After is called copper bottom. So again, the before is the same, but the after, there's these copper atoms at the bottom, and that's the red stuff. The rest, the chlorines and the aluminum, these are up above the red stuff.
When it's like aluminum color was gray, so when it's probably mixed with green water, this is a combination turn into gray. It takes the color of gray from aluminum to the color of blue in water.
No, it was a copper because the big combination is kind of like reddish and turned into pinkish color. It might have been the copper. The big combination was like the colors of each thing, and then mixed them all up. It got the grayish color on the top of this.
Okay, so yours is most like this hypothesis. This clump is everything put together?
No, because it was like little flakes of stuff. And it wasn't.
So there's little flakes of stuff, and then there's gray stuff. Okay, so which of them is most like that?
Well, like the liquid on top. I think that they're trying to they're coming together. They're like coming together. Right here really slowly. And one of them break apart.
Go ahead, break it.
When some of them trying to break apart, then they add a new piece and other new pieces. Depends, like new pieces come back, old pieces come out, new pieces come back. Like basically, it's keep coming back because they're all flakes.
Yeah, I agree with copper bottom because copper is when copper is a solid, it has the brownish reddish color, and according to the table, the color of copper is red and it's more dense and it sinks. So I think that in the copper bottom it shows the copper. On the table, it shows that copper chloride dissolves. So we thought that the copper it dissolved and it sank to the bottom, and that's what caused it to make the red stuff.
Trinity, do you want to ask a question?
You said it was brownish red. What made it brown?
That's when it's a solid. When it's a solid, copper is like a brownish reddish color. That's what we got that. Copper is the red stuff at the bottom.
So what happened to the chloride part of it?
We think that the chloride, it, yeah.
You think the chloride got mixed with the water? Like turn it into like grayish color?
Disagree with what I said?
So why don't you turn and tell your neighbor if you agree or you disagree and why and be ready to share? I agree.
I disagree with them because I think that because copper is red, and so if it was just copper, it'd be like very good. And when I looked into the class, I didn't see red, I just saw like a brown color. And so there's other chemicals that are with the copper, so it would be like a darker.
Yes, I want to respond to Journey.
I disagree because like if it was color change, the red stuff in it is copper chloride, and copper chloride dissolves, so you wouldn't be able to see it. And the color of copper chloride is blue. That's like in my group we agree with copper bottom because on the chart it's the color red, which is what we saw in the class, and it sinks, and like we even saw the color of the copper.
So I like how Letitia's bringing in some evidence from something that we learned. So we looked at a map that showed where Primelephas migrated and where elephants and woolly mammoths existed. So before, put your hands for a second, I'm glad you want to talk. But before we move on, here's what I want you to do. I'm going to give you these little squares, and you and your partner are going to look at these squares. They're evidence squares. So go ahead and look at the first one. And they're all based on things that we've learned in class or we've discussed. So I hear a lot of great discussions, but I want to focus us on the evidence to see if that supports your idea or not. So everyone look at evidence box number 1. Mammoth fossils are not found in Asia or Africa. Now, does that support or refute your hypothesis? Think about it for a second. Maybe it doesn't go with your hypothesis. Move on to evidence piece number 2. Primelephas fossils are millions of years older than mammoths. Yeah, because you have 2 people in your group. So go through
skin will be darker, but my offspring will not be born darker.
Well, we gotta look at the ones that support our hypothesis.
So are you saying that these match up with hypothesis 1 and 2? Or are you just sort of evaluating whether you think the evidence is true?
We're evaluating to see if the evidence is true.
And then go back to these different hypotheses and see which of these pieces of evidence explain.
Oh, but this one's saying that it
Chain physics and
traits.
So
But this is saying that the timeouts was
migrate and chose to change physics trail to survive.
Trait.
Whatever. Migrate and chose physical trait to survive. I tell you that.
So if you're like in Africa or Asia and you just go to Antarctica, you're just gonna automatically go for, like, he's gonna say it's too cold over here.
No, they probably gonna like make a baby before they go into the area.
Exactly, but this is saying it can change your physical traits. So that's what
Migrate. If migrate, that means you're gonna born.
But then it says to choose physical traits to survive better in a specific environment.
Okay, and then tell me which one you would choose. Put right there.
Specifically, another learning with the evidence-based explanations was we never really, well, we did teach what evidence was, but we realized with these, we were always giving them these cards, and we're like, oh yeah, we talked about this, remember? Like, this is the evidence you learned, and they didn't really remember, and we gave them some cards that had evidence, and then this piece of paper that had hypotheses that we had written for them, and we're like, well, the evidence is fact, and they started arguing about which evidence they agreed with instead of which hypothesis evidence backed up. And so this idea that evidence is fact and hypotheses are ideas didn't really get through to them, and so that's one of our next steps is working on having the students help to generate more of the evidence so they have more of a connection to this evidence is stuff that you have seen in class, and we remember this because you wrote this down as evidence, and the hypotheses are our ideas about what might happen, and so hopefully getting them to take a little more ownership over matching the evidence to the actual hypotheses.
That is not what Samoa was, right?
Obviously, that's obviously true.
This is how. No, that's Seattle. Towards the summer. This right by the equator. This is Samoa. This Samoa is not right by the equator.
Yeah, it is.
This is like Seattle. Okay. No, it takes a year to go around the sun.
Number 1. I think it's number 1 because like it says Chile had a shorter shadow one, so it's more towards the sun. And some, you know how like this bird said, like Samoa's like right here, and then like Samoa's like not facing the sun right here. Seattle is. Now it's
Then we came back and we're like, well, we like the cards, we like shuffling around, we like that they're using evidence and matching them up with these hypotheses, but we need to break it down a little bit. So we went earlier in the unit with fewer pieces of evidence and fewer hypotheses, and instead of waiting for it all to build up at the end, we had them go in partway through and do the same, pretty much the exact same activity, but just with smaller amounts of stuff, and that worked way better. And then we just kind of kept refining that as we go. So the big thing we got out of that was that we need to, that model or that, like using evidence and using that activity, we need to come back to it several times throughout the unit. You can't just save it all up for the end. Like we do it, we don't really have a whole lot of evidence at the beginning other than background knowledge, but then coming back to it 2 or 3 times through the unit so they can start eliminating some of their hypotheses and combining some and trying to think of what works as you go through. And we